Okay. Thank you. Okay, so what I want to talk about today is what is DevOps, what it's used for, and focus it somehow on internal developer platforms. You will see why very, very soon. So let's start the introduction. This is me after you ask me questions, so think twice. I work for Upbound. We're a company behind Crossplane. You will see Crossplane soon. Twitter, it's not important. I'm going to skip all this and let's jump directly into what really matters. So usually when I speak with people and they tell me, hey, well, I ask them, what do you do? What's your role? I'm DevOps, right? I always get different answers what DevOps is. Nobody really knows, right? Usually it goes something along the line, hey, I work with containers, or I do Kubernetes, I'm in cloud, I'm doing CI/CD, I'm a Jenkins moderator or Jenkins administrator who realized that it pays better if I change the title to DevOps. Usually something along those lines. Anyways, all those things here that you see here, right, they're just tools, right? They do not, working with any of those specifically does not give you entitlement to call yourself DevOps or anything else for that matter, really. What really matters is how can we service developers, and can developers use those tools, right? If you go to a average Node.js or Python or average application developer, because I just made a mistake. I said developers. Everybody's a developer, right? Nobody's copying and pasting commands from Word documents anymore. So application developers, they typically cannot use any of the tools that I mentioned before, or all of them, for certainly not, for a simple reason, because it takes what? It takes a couple of years to figure out AWS, all the services that they have. It takes like 2 years to figure out Kubernetes, and once you figure out Kubernetes, you need half a year more to figure out service mesh, and after that, a couple of months to figure out storage, and after that, just continues, right? So nobody can really know all those things. And then the logical question is, what do we do with application developers? Because that's what really matters, right? The applications we are developing, they're the business of our companies, and that's what really matters. Can the developers use all those tools together? Because eventually what we do want to do is to shift left, right? We want to enable everybody to be self-sufficient, right? I hope that nobody anymore is working in a model that, hey, whenever you need something, you open a Jira ticket, you wait for a month. If I have time, I will do for you, right? So everybody must be self-sufficient because that's the only way to be efficient. And then the question is, how do we do that? The first thing that you can do, and I've seen it actually in probably like 50% of the companies I've worked with, is the easiest way to become self-sufficient is the same model that people use to become full-stack developers, which is silly. And that is, hey, here's a credit card, here's AWS account, here's Kubernetes, go and do stuff, right? Deploy your application to production. Be a superhero or something like that. That simply does not work. What does work, and the only way, at least in my opinion, to move forward, if you call yourself DevOps or SRE or whatever, doesn't really matter, is to create services that everybody can use in your company. And through those services, to enable developers to be self-sufficient. And those services can be anything, right? It really depends. How do we define an application? What is backend, what is frontend? How do we deploy that application? How do we observe that application, and so on and so forth, right? So think of services that you should be developing, or somebody should be developing in your company in the same way as what AWS is to you, right? AWS provides services that we consume, but those services are very generalistic. They're building blocks because they need to cater everybody, right? We need to create another layer on top of things like Kubernetes and cloud and what's not that will be specific to what we need, right? Whatever the rules are, whatever the needs are of our company. And what we do, what we call that something today is internal developer platform, right? I mean, to be honest, most of the companies were creating internal platform for a very, 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 very long time. But now that became a bigger focus in the industry than it was in the past. It's internal because it's meant for internal usage, right? So you can think of AWS as being external developer platform or something like that. This is internal. This is meant for you only. It is focused on developers of application developers, and it's a platform, right? Everybody knows what a platform is. So in a nutshell, what internal developer platforms are is very simple to explain. It's a layer of all the tooling and all the processes that you have in your company, right? It abstracts all that tooling and all those processes so that they're easy for everybody, right? And what those processes are, again, depends on you. It can be security, it can be deployment, it can be testing, it can be anything, right? And the ultimate goal is what I mentioned before, shift left. If you're not familiar with shift left, think of it this way. Who doesn't know what shift left is? Everybody does. You're liars. Statistically, at least 50% say they don't. But okay, so for two of you who are truthful here, shift left means that if you have a process from the idea until production, typically on the left side of the process, we have developed, write code, maybe some tests, and so on and so forth. And on the right side, we have operational parts. This is how we deploy it here. This is how we run tests. This is how we do this and that until it goes to production, right? We want to move all those tasks to the left. We want to enable developers to do all those tasks themselves. Again, when I say developers, I mean application developers. And ultimately, that's the goal of how we see operations today, right? It's not anymore about waiting for somebody to open a Jira ticket and then checking whether you're in a good mood or not to do something for them. It's about doing precisely that. It's about enabling developers to be self-sufficient. And that's very beneficial. It's very beneficial for developers because all of a sudden, developers do not need to wait for anybody to do something. Hey, you need a cluster. Here's a button. You need this. Here's another button, and so on and so forth. And it's very beneficial for everybody else because all of a sudden, you're not doing the repetitive tasks over and over and over and over and over and over and over. You see how boring it is? Again, you can dedicate yourself for doing something that matters, right? So I will not go into details why self-service. Everybody knows why it's more efficient to do something by yourself if it's easy than wait for somebody else. You're more productive, you have this or that. If you're not familiar, read Dora report, DevOps something. It goes into much more detail about why do we want that, right? Now, when we talk about platforms, there are essentially 4 things that we need to think about, right? 4 very high-level aspects of those platforms, right? We need to be able to change the desired state. We need to be able to specify what is it that we want to have, right? I want to have a cluster. I want to have an application running in production. I want to have this or that, right? Then we need to be able to perform certain actions, like build your binaries, build container images, run tests, whatever those actions are. We need to be able to converge that desired state into the actual state. So whatever I want is what something becomes. And finally, we need to be able to observe the state of that something after it's converged, right? Because it's not enough to say, I deployed to production, I'm going to Hawaii. You need to make sure that it continues running. Now, if we would be starting from scratch, and I must stress this a lot, this is about starting from scratch. I understand completely that there is legacy. We cannot always get to where we should be. Some of you might have mainframes, right? Who's working in a bank here? Nobody. Again, liars. But if we would be starting from scratch, more or less, this is how that system would look like, right? In a very simplistic, high-level view. We would have, I don't have, this doesn't work. Anyway, at the top, in the middle, we would have some layer through which everybody can perform certain operations, can do certain things. We call that internal developer platform. When I say we, I don't mean me and my friends, I mean industry. Now, that layer can be anything, right? It depends really on the needs that somebody has, right? Some people like web UIs. Some people like CLIs, terminals, IDEs. That layer on top can be really in different formats. It depends what you're comfortable with, right? If you would ask me, it would be only terminal, but then I get fired when I say that. And below that, we need some kind of API, right? We need to be able to communicate, establish communication between that layer of internal developer platform and something else, right? And Kubernetes is a logical choice for that API because it's the only platform, the only API that we have today that almost everybody agrees is worth investing in, at least from the API perspective, right? Now, such an internal developer platform has two functions, right? One is to define what you want. I want an application, right? I want a cluster, I want something. And that's what we call the desired state. That's what we store in Git, right? And if anybody asks why Git, we're going to have trouble. Then we have this actual state. That's what something really is, right? Those are your AWS accounts and Azure, Google. It could be on-prem, right? Servers, right? Servers and services, right? We are moving more and more towards services. So it doesn't have to be that you own a server. You might be owning a Google Cloud Run application running somewhere. It could be Splunk. It could be Elastic. It could be anything. Below those services are some servers and clusters and database servers and all the good stuff. And finally, we have our applications. All that combined is the actual state of our system. Now, the real question over here is, how do we manage to create custom services that everybody can be happy with? And how can we converge those custom services from the desired state, which is Git, into the actual state, which is whatever, servers, right? And the logical conclusion, again, is Kubernetes. Now, the one thing is very important to understand about Kubernetes. Most of the people still associate Kubernetes as something that runs containers, right? Which is a tiny fraction of what Kubernetes really is. Kubernetes was never designed with the purpose to be something that runs containers exclusively, right? Kubernetes is an extensible API with control loops and scheduler, and it was designed from the very beginning to be a control plane, right? To be something that controls the state of your something, whatever that something is. I'm intentionally saying something is confusing, but I mean services, applications, infrastructure, whatever that something is. And the way how we accomplish that customizability of Kubernetes is through custom resource definition, right? So today, whenever you install some third-party application, if you install Argo CD, if you install MongoDB in your cluster, or so on and so forth, most likely you will get, even without knowing, you will get custom resource definitions. All those applications are extending the capability and the API of Kubernetes through custom resource definition, and then when we want to instantiate that something, we're creating custom resources. And now those custom resources can either interact directly with your cloud, with your servers, with your databases, whatever, or they can interact with some other tools and run your pipelines, schedule something, define your access control, and so on and so forth, right? Kubernetes is the bridge. Kubernetes is a control plane that manages the states between Git and the actual state, and it extends itself to be able to manage all the tooling that we have today. Now, the tools, when we talk about tools, again, I'm stressing that this is about starting today, right? How would we design the system starting today? We would need to pick some tools. We would need to be able to define what we want, to write some specifications. That's Kubernetes custom resource definitions. That's kind of easy. We would need pipelines. Nobody cares about pipelines anymore. They're becoming commodity. Whatever you like using, it's fine, really, as long as it's not Jenkins. I've worked with Jenkins for 10 years, so kind of I have the right to say something horrible about it. We need to be able to synchronize those states. That's the most critical part today. That's Argo CD, that's Flux. That's Rancher Fleet, maybe, in a year. We need to be able to orchestrate our infrastructure. That's Crossplane, that's SEK, that's any infrastructure as code tool that you might be using today, as long as it's made to work as a Kubernetes operator, as Kubernetes extension. We need something to orchestrate our applications. And again, I'm not talking about applications running in Kubernetes. I'm talking about applications running anywhere. That's open application model, probably with kubevela, or maybe Crossplane, a couple of others. RBAC, nobody cares about RBAC anymore because the only access to your system is Git, right? You're not allowed to access, at least in write mode, your system directly. So that became extremely easy. And we have the process, right? And the process is very easy. Very easy, relatively easy, right? If you have more than, I worked as an architect long time ago, right? And I know that my work was valued by how many arrows I can put between boxes. So I made a diagram for you. Anyways, the simple thing is that more or less we're all doing the same thing, and that same thing is that we are writing some code, we're pushing that code to Git. When we push that code to Git, two things are happening. First, we are running one-shot actions, actions that are executing only once for every commit, those testing, building, all this stuff. We have GitOps, meaning that we're continuous reconciliation between what is in Git and what is in your clusters, in your servers, and so on and so forth. And all that becomes actual state somehow. So I'm going to skip all this because I see that you're getting bored. And I'm going to show you in action. How much time do I have? 28 minutes. OK. Let me show you in action, actually, how all that, not all that, but how part of that work looks like, right? I don't like doing slides for a long time, and this is horrible. Wait, look at it. OK. So over here, not over here, over here, I have Argo CD, right? And I already pushed a couple of things, couple of definitions to Git, mostly because some things take half an hour in AWS. AWS is extremely slow. But that does not really matter now. What does matter is that I forgot something. Oh, my God. Look at that. I'll be back. Speak between yourselves. I need 5 seconds. OK, there we are. OK, so let's do something live, right? Let's say that I'm a developer right now, and I want to create 2 clusters, right? I want to have 2 clusters for my applications. One cluster that will be for development, and another cluster that will be for production, right? And remember, I'm a developer. I will tell you if I stop being an application developer at some moment to show you some other things. But how can I do that easily, right? Now, imagine that an operator in my company, SRE, or Kubernetes and cloud and everything else guru, already created the services that I can use. And I can use those services by creating writing few lines of YAML, right? And those few lines of YAML, first I'm going to push them to Git, and then I'm going to explain what I did, simply because after I push it to Git, it will take a couple of minutes until Argo CD creates everything. You will see it in action in a second. So let me first push things to Git. No, that's the wrong command. I didn't want to do cut. I wanted to do CP. Horrible. Examples, Kate's. I knew it. Examples, Kate's, Sivo, no claim, this is the one. And I'm going to push it to the directory infra. That's a directory in my Git repository that Argo CD is monitoring. I know why it's so warm. And I'm going to push one more file. I'm going to explain everything, I promise. I'm not going to explain everything because I will not have time, but I will pretend to explain everything, so it will be almost the same. AWS, EKS, YAML, right? So I've copied 2 files to Git. I'm going to add those files. I'm going to commit something, and I'm going to push it to Git, right? That's what I do as a developer, right? I write something, I push it to Git, and that's where my job ends, right? Now, let me show you what I pushed. Let's say that I want, I said already, a cluster that is for development, and somebody told me that I should use Civo. If you're not familiar, Civo is a cloud service like AWS, but mostly focused on Kubernetes, and what makes it special is that it's 5 times cheaper. Now, somebody in my company created something called a service called Composite Cluster, right? This is made specifically for my company. This doesn't come out of the box, right? Somebody made it because somebody defined how I can create stuff, how I can manage things, and what should happen in the background. I will show you what happens in the background. So I, as a developer, I defined something called Composite Cluster. I'm saying that it should, you see composition ref name, that it should be, there are different variations of that, different implementations of that service, and I want to have a cluster in Civo. And I'm specifying 2 parameters. The size of the nodes should be small, because I don't really know whether it's T2 something something or T3 something something. Nobody understands the sizing in clouds. And I want to start with 1 node, because that's enough for me, right? And the other one that I showed is this one, AWS EKS GitOps, no claim, right? Now, this first part is exactly the same, or almost exactly the same. The only difference between what I was doing before and what I'm doing now is that I'm saying, hey, this second cluster should be in AWS. I still have no bloody idea how that thing works, but I can consume it as a service because somebody extended Kubernetes for me, and now it's very easy. I'm having medium-sized nodes. I want us to have a cluster that starts with 3 servers, and that's about it, right? And since this is production, and we should do things seriously in production, meaning I shouldn't do kubectl apply, I shouldn't do SSH, and all those silly things that nobody should be doing, I want to enable GitOps in that cluster, so I'm using yet another service. This is all extensions of Kubernetes, saying, hey, I want to define something called GitOps. I want it to be Argo CD, and I want it to use a cluster that will be created in the future, and it will use the cluster through a secret called ATEAM EKS cluster, right? And this is the last line. That's a repository through which I should be able to define and run things in my cluster, right? And all that was already pushed those 2 files to Git. And I should have it all running very, very soon. Now, if I would be an operator, right? If I stop being an application developer and an operator, then I would probably want to see what was created out of those 3 manifests, right? 2 of those clusters and 1 of those GitOps, right? And if you're very, very patient, there we go, right? Those 2 manifests, and don't think that I'm cheating, because I am. I executed the same command an hour ago, because it takes half an hour to do stuff. Anyway, those 2 manifests that are custom-made for my company created a cluster in Civo. You can see it over there. That's easy, because Civo is extremely easy. But then in AWS is when you start getting headaches, because to run a cluster in AWS, you need the internet gateway, you need the VPC, you need the route table, you need a couple of subnets, you need a security group, you need a cluster, you need a node group, and you need a couple of roles and policy attachments. And then once that cluster is up and running, you need to install things in that cluster, because cluster alone is nothing, right? You need some observability, you need a bunch of other things, right? And all those things is what I'm getting by consuming the service created by somebody, right? And when you look at those things, and then you say, somebody still says, no, we can enable developers just by giving them a credit card to do stuff in AWS. You see how wrong that is. So that's my cluster, that's my infrastructure, right? And by the way, this is all created and made possible by Argo CD. This is for people who get dizzy by seeing terminal for a long time and like pretty colors. This is the same thing, just more colorful. What should we do next? Let's say that I want to now use that cluster, right? I'm now going back to being a developer. Oh, I forgot one thing. I just realized that I forgot one thing. what did I forget? I forgot to execute something, and I forgot what that something is, and now I feel very embarrassed. This is what you get with the demos that are prepared 2 hours before the talk, right? What did I forget? Yeah, I forgot to add the secret. No, that's not what I forgot to do. Yeah, actually, no need. Everything is fine. So if I want to interact directly with that cluster, I need to be able to connect to it, and you connect to Kubernetes cluster to something called kubeconfig. And the process that created a cluster created a secret for me, and I can just consume that secret by writing it down, right? kubectl -- namespace. This is now operations. Don't worry. You won't have to do it as a developer. Get secret a-team EKS cluster. There we go. Output JSON path. So whomever is a developer today and wants to become an operator, look what you have to do. Horrible. Data kubeconfig, and then close it. And then if you're religious, it's very beneficial because you can start praying right now. There we go. Let's see whether it worked. There we go. That's a connection to my cluster, right? OK, so let's take a look whether that cluster is up and running, whether it's really working. So I'm going to say kubectl kubeconfig, the one that I just got, get nodes, right? Did I get nodes? I'm nervous. Right? This is the cluster that was created for me, right? By me, myself, but the other me, right? The developer me. Now, let's say that you want to see how I created those services? Maybe that's useful. Let's do that. Let me show you how I, as operator, accomplished to provide those services to my people. Sounds cool. So there are two things that I had to do to be able to create such a service that others can consume. First is the definition, right? And that's OpenAPI schema, right? This is standard thing in Kubernetes. We actually extended standard thing in Crossplane, so it's slightly more of a standard or less, depending on how you look at it. But what really matters here is that I defined how to extend Kubernetes by saying, hey, create a new custom resource definition that will have the fields, version, and node size, and minimum number of nodes. Those are all the fields that I used before, right? And then I had to create an implementation. And this is now where it gets very complicated, right? This is me saying, hey, whenever somebody chooses to use that new definition and selects to use EKS as implementation, AWS, because I have different implementation, this is what will happen in the background. I will take their input, I will take the parameters, and then construct all the different resources that are required. Like here you can see the cluster, and then there is a node group. Here we are. And here is where I'm transforming medium to what that means in AWS. I'm here defining role, and so on and so forth, right? A lot of work that you would need to do anyways. No more. OK. And you would need to do anyways. So if you're using Terraform, you would do the same thing in different format. Pulumi, you would do the same thing, and so on and so forth. But what we're doing now is providing that something as a service, internal service, right? Now let's see how I can modify something. So for example, if I would like to change the number of nodes in my cluster, in the development cluster from 1 to 3, I just modify my manifest, git add, git commit, something else, and git push. There we go, right? As long as you trust the system, I mean, I assume that you have observability and you will get notifications something goes wrong. A few minutes from now, my cluster will have 3 nodes, right? Extremely easy. So what else? How much time do I have? 15 minutes. Cool. Let me see. What else can I do? Let's do, no, this is boring, no. It's also, did they update this? Probably not. I think that this is an old presentation. I'm talking about the wrong thing. What else can I show you? Let me see. Okay, keep pool. Yeah, I was really using the old presentation. Excellent. Now we can improve. Yeah, definitely wrong presentation. There we go. There we go. Don't look. This is confidential. OK, now let's see what else can I do. This is boring, boring. OK, let's deploy an application, right? Now, if you're an application developer in Kubernetes, you would need to define a deployment or a stateful set. You would need to choose between the two. You would need to define a service. You would need to define an ingress. You would probably need to define virtual service, storage, probably 70 other things. But what I did here is something much, much simpler. So what I'm going to do is deploy. I'm going to push it to Git first. No, let me show you first the output, right? Instead of defining all those things, I extended Kubernetes even more. I said, let me have a resource type called app that will define how we run applications. And those applications do not have to run in Kubernetes. I'm just using Kubernetes as a control plane that sometimes might run it in itself. So I'm defining an application, say, hey, I want an application that is going to be called silly demo. That application should be the backend application with the database, right? I want to make it hard. And I have a couple of parameters, only the things that matter. And I would like to have a database here, SQL, that will be a locally running Postgres, some version 13.4, small database because I'm cheap. And this is most important here, the last two lines. If application is to use that database, it will need a secret with authentication to that database. So let me write that authentication as a secret in Kubernetes. So I'm going to copy this. Examples, app, backend. By the way, this stage is made for short people. I'm going to push this to this directory. And I'm going to edit and commit it. I'm getting push it, right? Now, let's say it will take a couple of minutes until Argo CD figures it out and applies it to the cluster, and Kubernetes creates everything. I'm not going to wait for that. Let's say that I want to run this same application in production. Now, if I would like to run it in production, I would do something like this. App backend, this is the file. I prepared it in advance. There we go, right? Now, this is the same thing as before. It's called silly demo, more or less. It has a couple of parameters. It's a backend with a database. But since it is a production, I don't want to run my database in that same cluster. I'm going to use RDS, right? AWS service for Postgres. So I'm still defining the same thing, right? Because this is the power of services. I'm still running SQL. The only difference between this and what I had before is here in the reference. I'm saying, hey, I don't want that database, that same database running in that Kubernetes cluster. I want it to be RDS. That's the only difference. So let me push this here, app. What was the name? Backend AWS something something. There we go. And Postgres and no. There we go. And I'm going to push it to the directory apps, git add, git commit, git push. Always write good commit messages so that people can understand what you did. So let's take a look at what's happening now in my cluster. Kubeconfig YAML. get, what did I define? I defined something called apps. I defined something called SQL. And only application is there running. The other application is not there, and the database is not there. And the reason why it's not there, because the Argo CD did not have enough time to figure it all out. But if I refresh it, and no, this is wrong Argo CD, because I have a different Argo CD in a cluster. It will appear soonish. I'll give it a minute more. How much time do I have? 9 minutes. OK. So while waiting for my application to be created and my database in AWS to be created and my database in a cluster to be created because it's production, development, and so on and so forth, it's going to take a couple of minutes, and then we can start with questions. Yeah, let's do questions while waiting for this to happen. Did I confuse the hell out of everybody? Probably I did, right? So I worked as a consultant a long time ago. You remember how I said that I worked as an architect in a consultancy a long time ago? That's when I learned that if you want to be very successful in your job and to be well paid, you need to confuse everybody so they say, wow, he must be good. This is my YouTube channel. While waiting for the application to happen, check it out. I have a podcast as well. Check that out as well. All free, good stuff. And what I was using today is Crossplane. This is the open source project. That's the project I'm working on. I work for the company Upbound, but I'm not selling you anything today. I can sell you something later if you want. And that's about it. That's all the information you need. Now, questions. Come with questions while I'm waiting for my application to maybe, most of the demos fail. It will work later. Questions? I think that somebody comes out of the door and reads the questions, right? Probably. Thank you, thank you, thank
you. We have a lot of them as well, but I'll try to group them in a way.
A lot of time. Yeah. Or you want to go for a coffee?
Well, I think it's lunch now, so.
I know. OK.
OK, so I'm going to try to group them a little bit because there were a number of them that were around, with all these tools.
Yes.
Aren't we hiding knowledge from developers or kind of creating new silos? Or
no. No, I don't think we're hiding knowledge. I think we're creating new silos because, and I think that's where most of the companies made a mistake, right? Most of the platform teams that I've worked with in the past, and I saw it before, think that, OK, we're going to create something, and then we're going to go to our CTO, and then we're going to convince him to make it mandatory for everybody to use that something, and so on and so forth. I don't think that any developer should be forced to use anything. If they like your platform, they're going to use it. If they don't, they're not going to use it. And if they don't use it, that means that you did something very, very bad, right? So I see platform engineering. I see application developers as customers of platform engineers. You need to figure out what they need and what is the level of abstractions that they care about and what is not, right? If you have developers who like going directly and operating directly in Kubernetes and kubeadm and all the funky stuff, I think that's absolutely amazing, right? You do not need anything then. If they don't need anything, you don't need anything to create for them, right? So whether it's abstracted too much or not depends on the needs of the people you serve.
OK, that one has a lot of likes. They say that, OK, if these development platforms are so great, why not many Fortune 500 use them, apparently, which I don't know because I've never worked for any of them, so I don't know how it is.
Let's start with, I don't know, can somebody Google what is the top kind of companies? Probably the top is Google or Apple. They have internal developer platform. The second is probably Google. They do it as well. The only exception is that they do it for 20 years already, and we are starting right now. Who is also big? Like Netflix is probably huge. as well. Spotify is massive. Now, by Fortune 500, if you mean I am in a bank that is still trying to figure out left click or right click.
Yeah, or containerized COBOL or something like that.
No.
Right, so that's an interesting one. So, and they are sponsoring here, so I guess everything goes together. So in your opinion, do you think local stack is a good way to help, at least, for the dep or test environments, or just have let's say, an AWS testing account? Or a bit of both?
I used local stack in the past. I don't use it that much because there are some deficiencies, there are some issues, and then since I'm rich, I go directly to AWS. But local stack is a great project. Try it, use it, see whether it makes more sense. I don't want to say use it or not use it. It's great. Try it out.
Okay.
But if you want to save money, also say you don't have to run in AWS. You have Civo, you have DigitalOcean, you have Linode. I'm very much in favor of using services for everything.
Okay, so 3 people, at least they like them. They're asking about tools I don't know, something called Backstage or Communitech. Do you know them?
Yes, so,
okay.
because
I don't know all the tools in the world.
So when I was talking about internal developer platform having a layer that can be terminal commands, like what I did today because I'm a freak, or web UI, Backstage is probably the best option to build your own web UI for your internal tooling, for your internal platform, right? That's almost certainly the best option you have today. I think it started in Spotify. Another proof that other companies use internal platforms, after a while they open sourced it, and it's absolutely awesome. First day, you wanna open a window and jump how complicated it is, but once you figure it out, it's cool. It's great. Try Backstage. What was the second one? Kubernetes?
Communitech.
I don't know.
Well, maybe it's a typo. So maybe it's a typo. So you see? Oh, yes, sorry.
Humanitech? I bet it's Humanitech. I bet it's Humanitech.
I don't know about this.
If it's Communitech, I never heard about it. I don't know what it is. If it's Humanitech, no.
Okay. Right, so there's one that I guess there's probably some angry developer writing that. What happens when these platforms fail and the developer just cannot work? What would be your advice for that angry developer?
Yeah, I mean, it's the same thing. It's not only for platforms. When our services fail, we need to fix it. But it is the same thing whether it's internal tooling or external tooling, right? The same thing I can ask an application developer. What happens when your web page fails? You fix it, right? Now, you typically, and this is where first of all, internal developer platforms are it's less important to fix it fast than user-facing applications, because if your layers on top of Kubernetes or whatever stop working, your system is still working. You just cannot make a new release, so if it's down for an hour, it's not a big deal, usually. I mean, it is a big deal if you have 1,000 employees, but not such a big deal as if million users stop using it. But yeah, when something is down, you need to fix it. I don't see what's the problem in that.
And what about the human factor? Because I've been in places where developers are not even allowed to contribute to that. Well, maybe the question is with the job, but you know.
If your idea of a business is to make everybody as unproductive as possible, but not allowing them to do anything, then I think you have a serious problem over there.
So that's a problem for the CTO, I guess?
I mean, personally, I'm a social. I would like to get rid of all the humans, right?
So am I.
Most of the time, they're the cause of all the problems we have. But as long as we have to live with them, of course, we need to enable people. And it's kind of silliness of companies that say, hey, you cannot do this, you cannot do that, but you can write code that can mess up everything anyways. Kind of, it's silly.
Okay, so I think we covered most of the questions here. If there's any other question in the audience or something, anyone raising hands? No? Probably you are hungry now.
Now that I see you, you don't dare, huh?
Yeah, you don't dare. You have me there.
Anonymous only, okay,
checking everything and all that.
I see.
All right, well, thanks, Viktor. And
thank you.
Have a good lunch and see you later.
Thank you.